Hello everyone, I'm Xiao Gang. Okay, now we'll cover the two most important sections of this chapter. One is replicating actor properties, and the other is RPC. We'll ignore the rest. As we demonstrated earlier, in Unreal Engine, to use property replication, you mainly use these two macros, because they maintain the list of all properties. When you have this macro, the corresponding property will, every time its value changes, send the update to each connected client. Then each client will update the corresponding value to their respective version of this actor. Generally speaking, there are these two methods. RepNotify means replicating the property to a specific connection, and you can write some replication conditions or define some logic. As for RepNotify using, it mainly provides you with a RepNotify function so that the client knows this property. It was passed over, copied, and modified to make it convenient for you to compile the subsequent logic of the compilation. Of course, you can also use this locally practical, but if you don't write it here, then it won't be copied. But sometimes when we copy, we don't just copy the basic data. We can also copy some structs, because for some of our structs, they actually don't need to be copied, because it can provide some data. Then the third and fourth data can perform some calculations using the first two data. Then we can put these calculations on the client. We don't let the server do the calculations. Our server only provides basic data. Then the client can obtain this calculation. For example, when we calculate the player's movement direction for the next moment, we might need to synchronize the acceleration or the direction of the player's current camera view, or the position of the current weapon. So we directly synchronize this basic data. We don't need to calculate all these things on the server and then synchronize our result. We can let the client calculate it themselves. This is completely fine. Okay, then how do we do it? Actually, the simplest way, then just do it directly through repractic. But this one is a special case. He wrote a Python actor constructor. Then inside the Python actor constructor, he enabled repractic true, and at the same time, here, that is he through, but overriding the replication function. This method, it still has to be written. Then he directly through this method registered this input into it. Now let's guide everyone to complete the code for this. Okay, then let's go back to our project site. Here, we will first create a new actor and then put it in. Good. Okay, then on our end, we will start writing this code. First, let's remove the constructor. It seems there is no constructor here. Remove the constructor. This part. Okay. Remove the constructor. Then let's first confirm that the compilation can pass. Then we will continue writing below. The current one should be compiled. We adjust the build. It should be able to pass. Okay, good, it can pass. Then this begin play and this tick. We don't need either of them. Let's just delete them. Okay. And here it is, public. Then we give it a health value. This health value is given as a Ryu N32 type. Okay, after giving this health value, here it writes a generated actor constructor. Let's take a look at this constructor. We need to create its implementation. Okay, in this implementation we are creating, we enable its replicates property. This constructor, I haven't really used it much yet. Let's see if it compiles successfully. Wait a moment. Obviously we need to include the header file here. Include the relevant network header files. Then next we override this. Overload this. Actually, it's called override. It should be override. Yes, it should be called override. Okay. Okay, then we'll implement it here. The implementation is quite simple. First, we definitely need to call the parent class. After calling the parent class, we can add a derived property to it. Then this value can satisfy this requirement. Okay, we have a compilation error here. Let's check the reason for the compilation error. It should be a mistake here. It can change this value through network replication. Still getting a compilation error. Let's check again. Then we find the reason for this compilation error. It must be caused by this. Then you'll find this thing. Actually, we search for it globally. You'll find that in the Unreal Engine. And this thing simply doesn't exist anymore. It's only inside this UHD. This place is just a hint. This thing is already obsolete, but it's left here so that it won't affect the old code. This is inside UHD. That's why in our Unreal Engine, inside the UHD, how these symbols are handled next. Right, in this place, so you can see it should be here. For those who are interested, you can study in depth things like UHT and UBT. Take a look online. Search for some materials and such. Then in our case here, we definitely shouldn't write it this way. So we will still revert it back to the original. Let's just write it directly like this. Let's not write this constructor. Okay, then it should definitely compile successfully. This proves that this document might be a bit old. I think, okay, this place indicates a compilation failure. The reason it won't compile should be here. The method he mentioned, we have already commented it out. It should be this place. We used this thing, so we need to uncomment this part. It might not find this method, because after you, it might need a restart. Let's handle it this way. Okay, let's compile it. Good. So with this thing in place, equivalent to our attribute, it can then be synchronized over the network. So how do we verify this? Actually, we might need to write a tick method here. We'll increase this health value by 1 every second, and then just print it on the screen. Then let's write the tick below. Then we implement this method. I don't need to change the signature. Let's implement it. Then we should call the super tick. And then here we modify this value on the server. It's relatively simple. Then we should be able to get world, because this actor, it must be attached to a world. We'll just not check for null like this. After get wild, then we go get night mode. Okay, we set it equal to night mod. We need it to equal this ds, right? We only do this on the ds because I think this way it's clear. If we are on the ds, then we modify this value every frame. Looking at this error here, it should be 1 extra of this. If that's the case, then we'll increment this value. After adding it on the server, we need to execute this change method. Right. So what can we do? We can write it like this, actually, because on both the server and client, we will go through it. I'll call a code over at the end that we can write on top. For this log, let's save some trouble. This log is the health message. And how much health is remaining, we can just put the health value here. Then output this information on the screen. We better distinguish between the server and the client. Obviously, this part is all on the client side, right? Yes, because when we launch, it will only start the client. Here we assign a cloud. We will only see this value on the client screen. Actually, the value on the server side is constantly changing. Let's start a test now. And here we have an actor class. So here we should preferably create a root node. I remember we explained this to you. If you don't create a root node here, then there will be a problem. That is, it sync component here, for if we assign a xg root component, okay, good. After completing it like this, we can then on our client see this health value continuously recovering. Okay, let's start a test now. Alright, let's create a new map here. We are using the C++ property section. Let's change the startup map. This might be because we moved the location. You see, these maps are all missing, but it doesn't affect anything. It should be CPP. For this game mode default, we'll just assign any one. Okay, After moving this map to the second position, actually, we can get it here and find it here. We can just drag it in directly. But we usually don't do that. We usually create a blueprint class to do it. We can just drag it directly like this. It has a root node here, no problem. Then we started in client mode here. Actually, let's start 2 instances. We can take a look. Why is there no effect here? It's because we haven't enabled this tick at all. So what should we do? Actually, we can do it this way. Let's delete this thing first. Let's create a blueprint class for it. Let's put it here. Put it here. Okay. Let's change the name. Let's enable the tick for this. Because its tick might be turned off by default. Okay, let's create a blueprint class here. We can give it a different name. It should be fine if we don't change it. Then let's drop this blueprint class in. We should change the name. Change the name to BP. Then we delete this part. Then we save it. Then drop it into the scene. Then we just open a client. Then you will see that this value is 0. This proves that something might have gone wrong here. That is, although it has been set to 0, this value has not been increased. Then we check what caused it. Now we have set a breakpoint. Actually, the reason is not that our code is wrong. It is actually here. You can see the 594 here. Then here we can... Actually, it won't come in. We wait for the next tick. It came in. Actually, this value, it has already received this change. But the reason here is that we wrote it wrong. This side is F%. We need to change it to D%. Only then will it work. Then we change the time show time to 0.5. We just need it to exist all the time. As for this K, we should probably just leave it as is. Let's take a look. Now let's test it by hitting it. Because we had a tick here at the beginning, we turned it off. So we didn't write it here. We just directly make it into a blueprint class. In this blueprint class, each tick might be enabled. We'll just leave it alone. This way, it's convenient for us to operate like this. You see, this way, we just confirm that the tick here is enabled. Inside here, modern is enabled, and tick is also allowed on the dedicated server. And in this group of ours, Repoetics, you will find that it is also enabled by modern. Then we place it into a scene. Then at this point, you start it. You will find that its health value has been it has been synchronized. And actually, if we open 2 of them, it is, right? Okay. So this is the first simple method. And actually, if you look here, you will find a very interesting phenomenon. If I open it here, you will find that it is 0. Did you notice? It turns out to be 0. Isn't this amazing? It's because in this place, we only allow it to run on this dedicated server. Actually, if you want to support other modes, you can also add a check. For example, on a listen server, you can also allow it to support this increment. So this is our first method.